When you walk into, a crowded casino or a massive transit terminal, the background music just feels kind of effortless.
Right.
Right.
Yeah, completely invisible.
Exactly. But the hidden engineering required to pull off that acoustic illusion is, well, anything but effortless. So today, our mission in this deep dive is to explore the source material for a $910 pair of commercial
Yeah.
speakers.
The QSC AD-S6-BK 6.5-inch passive loudspeakers is quite a mouthful.
It really is. We're looking at the intense technology required to make audio sound perfect in giant, echoey spaces.
Okay, let's unpack this, because looking at the specs here, I mean, this thing is a giant physical contradiction.
It is. It operates in two entirely different worlds.
Yeah, it's built like a luxury SUV, basically. Rugged on the outside to handle weather and dust, with this thick ABS plastic shell and a powder-coated grille.
Right, it has that IP54 dust and splash resistance rating.
Exactly. But inside, it's housing incredibly delicate components. We're
Hmm.
talking about a 1-inch silk dome tweeter and a weather-treated papery cone woofer. And that specific pairing, that's what allows the speaker to push a massive 116 peak decibels.
Wow, that is loud.
Very loud. And while covering a huge range of sound, too, from a deep 58 hertz up to a piercing 20 kilohertz. But what's fascinating here is the 16-ohm rating.
Oh, right, yeah, because normally chaining dozens of speakers across an airport is like trying to keep water pressure high in a mile-long hose.
That is a great analogy. Usually you need transformers at every single speaker to manage the flow, which, degrades the sound quality.
Right, it ruins the fidelity.
Exactly.
Okay.
Because this speaker has a high 16-ohm rating, it acts like a high-pressure nozzle natively. It completely bypasses the need for a transformer.
So you get high volume and pristine audio quality without the bottleneck. But blasting high-pressure sound into a giant concourse usually just creates like a muddy mess of echoes.
Oh, absolutely. It can be a total nightmare.
So how is the speaker physically shaping that output so it doesn't just bounce everywhere?
Well, that comes down to the physics of QSC's directivity matched transition, or DMT. Usually, high notes shoot straight forward like a laser,
Okay.
while low notes spill everywhere like a floodlight. That mismatch is exactly what causes those muddy echoes in big rooms.
Ah, I see.
So DMT physically shapes the speaker, so both the highs and the lows project in the exact same 105-degree cone. You end up with a completely uniform beam of sound.
That is super clever. The physical design is amazing, but here's where it gets really interesting to me. They pair this hardware with their QSys software platform.
Right, the intrinsic correction software.
Yeah. But I have to push back a little here, though. I mean, does their intrinsic correction software actually fix a room's bad acoustics?
That is a very common question.
Because, you can't just EQ away the physics of a terrible cavernous room. It just doesn't work.
You're totally right, and it's
Yeah.
absolutely not masking a bad room.
Okay, so what is it actually doing?
The intrinsic correction uses advanced voicing filters that speak directly to the CXD series amplifiers powering the system. It ensures a completely smooth power response right out of the gate.
Oh, so it's fixing the output before it even hits the room.
Exactly. By delivering such an accurate baseline performance from the hardware itself, the installer doesn't have to fight the room acoustics with extreme manual EQ tweaking.
Got it. So the software does the heavy lifting for the acoustic tuning? But, I mean, none of that precision matters if the heavy physical speaker sags an inch to the left after 6 months.
Right, just from building vibrations and gravity taking their toll over time.
Yeah. How did they solve the mechanical drift?
They completely redesigned the mounting bracket into what they call the X-mount system.
And the details on this mount are wild. They built these knurled surfaces, basically textured, grippy metal at the pivot planes, specifically to lock the teeth in and prevent any sagging.
Yeah, the teeth interlock perfectly.
And they stamped articulation marks right on the side. An installer can pre-configure the exact tilt they need while they're still standing on the ground.
Without reaching for a single special tool, too. And if we connect this to the bigger picture, in commercial integration, time and safety are everything.
For sure. I mean, you don't want to be fumbling with wrenches on a ladder.
Exactly.
Yeah.
An installer is often up on a precarious lift, a speaker that allows you to set the angle safely on the ground and then just clicks into a wall or ceiling in seconds. That is huge.
It just snaps right in.
Right. It yields perfectly repeatable results across an entire massive building, all while drastically reducing risk and labor costs.
So what does this all mean? Ultimately, these QSC speakers are a masterclass in blending rugged physical durability, smart acoustic software, and sheer mechanical ease.
They really are.
It takes an incredible amount of invisible engineering to make things look and sound easy.
It does. And the next time you are sitting on a windy outdoor patio or waiting for a train in a massive, echoing transit hub, look up.
Yeah, take a second to appreciate it.
Consider the sheer amount of unseen acoustic math, intrinsic correction software, and neural mounting hardware working silently above you just to play a simple background song.
It's mind-blowing when you really think about it.
It makes you wonder, as spatial audio and AI tuning become more advanced, will the architecture of our future public buildings be designed around the speakers rather than the other way around?